John deposits $1,000 into a savings account that pays 3.2% interest. How much will John have after 10 years? So this, since nothing is being compounded, this is a simple interest problem, and we know the equation for that is A equals P times 1 plus R to the power of T. So we can fill in a lot of this information, where P is the principal amount, which is $1,000 in this problem, times 1, and then the rate is 3.2%, which we have to turn into a decimal. So that will be 0.032, and T is time, so we'll fill in T as 10 because there's 10 years. So this is easy. We can just throw this into our calculator, which will give us 1,000 times 1 plus 0.032 to the power of 10. And this gives us 1,370 and 24 cents. So this is how much John will have in his account after 10 years. So now what if we say that this account gets compounded monthly? So this equation will change slightly. So instead of being A equals P times 1 plus R over T, it will be A equals P times 1 plus R over N times T times N. And N is the number of times it gets compounded yearly. So if we say that his account gets compounded monthly, we'll make N equal to 12. So A equals, the principal amount still stays the same as 1,000 times 1 plus 0.032 over 12 to the power of 10 times 12. So I'll just put this into my calculator once again. 1,000 times 1 plus 0.032 over 12 to the power of 10 times 12. So I get 1,376.54 after 10 years. So it is slightly more than he would get if it wasn't compounded at all. So finally, what if we say that instead of being compounded monthly, it gets compounded continuously? So with this is called the PERT function. So this is still the principal value, and this is the number E, the rate, and time. So everything stays the same except for this gets added into the equation. So the principal amount is $1,000 times E to the power of the rate, which is still 0.032 times 10, which is 10 years. So I'll put this into my calculator. And 0.032 times 10. So this gives us $1,377.12. So it's, once again, slightly more than being compounded monthly and a little bit more than being compounded. Not being compounded at all.